Hello, fourth grade. It is Thursday, the 16th of April, and we are looking at science. Our chapter is about the earth, geology, the study of the earth. And we are on 7.2, beginning on page 153, as you can see on the board behind me. All right, so I have my book all out and ready, and I'm going to begin reading. First thing we're going to do is we're going to look at the comp check and see what we are highlighting in this section of our chapter. Number 1 says, what is the spinning motion of the earth called? Number 2, explain what the Earth's axis is. Number 3, what is the Earth's orbit? Number 4, what amount of time is measured by one rotation of the Earth and one revolution? So number 5, there's 4, there's 2 parts to that, one rotation and one revolution. Number 5, what is the name of the force which keeps the Earth in its orbit? Number 6, why are there seasons? Number 7, where on Earth would you not notice a seasonal change of temperature? Okay, so those are things that we're going to highlight and talk about. All right, so let's begin reading. The Earth's motion. The Earth rotates, and there's a picture of a rotating top. Although you cannot feel it, the Earth is moving right now. Have you ever watched a top spin? We all have. The Earth spins in much the same way that a top does. We call this spinning motion of the Earth its rotation. Okay, so one of our questions was, what is the spinning motion of the Earth called? And so we just answered that. It says, we call this spinning motion of the Earth its rotation. Notice how your globe rotates. There's a picture of a globe. So if you have a globe, you can spin it. Okay, notice how your globe rotates. There is a stick going through the globe. One end of the stick is the North Pole. We talked about that yesterday. And the other end is the South Pole. The globe rotates on this stick. The stick represents an imaginary line which runs through the Earth. This imaginary line is called the Earth's axis. Okay? The axis does not point straight up and down. It is tilted. So imagine that this is the Earth's axis. Okay? This is not the equator. The equator is the imaginary line that runs around the center horizontally. This is the Earth axis, which is vertical but not straight up and down. All right? So our explain what the Earth's axis is. That was number 2. So let's read more about it. It says the axis is the imaginary line which runs through the Earth. The imaginary line, like I said, is called the axis. The axis does not point straight up and down. It is tilted. The surface of the Earth near the equator rotates at a speed of about 1,000 miles per hour. Okay, do we feel that? Are we moving 1,000 miles per hour? We don't feel that. It takes about 24 hours for the Earth to rotate once on its axis. What name is given to a 24-hour period of time? Okay, that's obviously a day, a full day. The Earth rotates from west to east. This is why the sun seems to rise in the east each morning and set in the west each evening. However, the sun is not really moving across the sky each day. Because the Earth rotates, people on one side of the Earth face the sun and have day, while people on the opposite side of the Earth are facing away from the sun and have night. Okay, so the sun isn't moving, right? It says there, the sun is not really moving across the sky each day. The Earth is moving. The sun's staying in its spot. The Earth is moving. So one part of the Earth, one half of the Earth is facing the sun while the other half isn't. So it's dark, light, okay? Day, night. So I'm going to read that again. Because the Earth rotates, people on one side of the Earth face the sun and have day, while people on the opposite side of the Earth are facing away from the sun and having night. As the Earth spins, the parts of the Earth having night gradually rotate until they are facing the sun. Then the other parts of the Earth have night. All right? So So when it says, explain what the Earth's axis is, it told us here that it's an imaginary line which runs through the Earth. An imaginary line that runs diagonally tilted through the Earth. Okay? So that's the axis. And so if I wish I had a globe, I don't have one. So imagine here's the globe. It's the axis, and it just rotates. Rotates. Day on this side, night. East, west. Okay? Now, rises in the east, sets in the west, in other words. All right, so let's look at page 154. The Earth revolves. As the Earth rotates on its axis, there's a picture there. You can see, looks like a stick. It's an imaginary line running through, and you could see the arrow showing you that it's rotating. It also travels in a path around the sun. We say that the Earth revolves around the sun. The pathway or orbit which the Earth follows is 595 million miles around. The Earth travels at a speed of 66,000 miles per hour as it orbits the sun. We don't feel that, do we? It takes 365 1/4 days for the Earth to revolve once. What measurement of time is 365 days long? We know that that's a year. We have an extra day in February every 4 years. We did this year. During leap year to use up the extra quarter of a day left over each year. So I didn't explain the Earth revolving around the sun as well as I should have a few minutes ago. So let's look at it carefully because it helps that we have a picture. I was trying to do it with the pencil in my hand and whatnot. So, but here we have a picture. So now let's look. It says the sun stays where it is, right? But the Earth moves around it. Okay? So this shows you a little bit more of a three-dimensional image. Even though it's not three-dimensional, it kind of gives you a good picture of that by showing the Earth swooshing. See the blue like swoosh around the sun. So here's the sun. So if this were the sun, the Earth is moving. That's a three-dimensional image. So if you could see that better. This is the sun and the Earth. The stick is the Earth. Let's say this is the axis, and the sun moves around the Earth. Okay? And that's where the expression, we say that the Earth revolves around the sun. All right? So it says the Earth travels at a speed of 66,000 miles per hour. We don't feel that, obviously, as it orbits the sun, meaning moves around the sun, and it takes 365 1/4 days for the Earth to revolve once. And we know that that's a year. How is it that the Earth stays in its orbit day after day? How does it not just drop? Jesus, as you know, the force that draws things toward the center of the Earth is called gravity. Gravity is what's holding you down to your chair. If it were not for the Earth's gravity, we would fly off into space. Did you know that the sun has gravity too? Because the sun is so much bigger than the Earth, it has a much stronger pull of gravity. The sun's gravity not only holds the sun together, it also pulls at the Earth and all the other planets, keeping them from going off into space. So that God created the sun to hold Earth, to keep the Earth from just flying off. Okay, we talked about all the different galaxies everywhere and how the Milky Way where our planets are is just one aspect of God's creation. And yet it's like everything, isn't it? That's how big God is. And so the sun, because the sun is so much larger than the Earth, it pulls the Earth and all the other planets and holds them all in place. Now, that's the way Jesus created it. So we give all glory to God, and everything that's created has come from God. And that's the way he created it to work. It's going to work that way all day, every day. You don't have to worry about one day the Earth snapping loose and, flying off into the universe. Not going to happen. What God creates, it works day in and day out. Okay? Forever and ever and ever. So, let's see. The sun's gravity not only holds the sun together, it also pulls at the Earth and all the other planets, keeping them from going off into space. Like I said, the sun's gravity keeps the Earth in its orbit day after day. Like I said, year after year. We can be thankful to God. Like I said, it's all because of God's design for setting up such an orderly, faithful system as this. Okay, so for our question, what is the Earth's orbit? We read that, that's number 3. We read that the Earth's orbit is its pathway around the sun. Meaning, where does it orbit? It goes around the sun. Its pathway around the sun. That's its orbit. Okay? And then we said, what amount of time is measured by one rotation of the Earth? And it says one rotation, let me find that. One rotation of the Earth is, okay, one rotation of the Earth around, I want to see how they worded it. What amount of time is measured by one rotation of the Earth? And we know that that's a day. One rotation of the Earth is a day. And then one revolution is 365 and a fourth days, which is a year. Okay, so one rotation a day, one revolution a year. All right, so let's move on. The seasons. We have a question about why are there seasons. We have seasons of the year because as the Earth revolves around the sun, its axis remains tilted at an angle which does not change. This tilt causes heat and light from the sun to strike the Earth in different ways at different times of the year. Okay, so that's a nice, thorough answer for why are there seasons, which is, oh, well, that's number 6. Number 5, we can go back to number 5 real quick. Number 5 is a no-brainer. What holds it in place? Gravity, right? Number 5 says, what is the name of the force which keeps the orbit of the Earth in its orbit? We know that that's gravity, and it keeps all the planets in its orbit. So that's kind of a no-brainer. But number 6 says, why are there seasons? We have a nice, solid answer there. And I'd like you to write that first paragraph. We have a nice, thorough answer here. And remember, I told you that when you write things in complete sentences, you'll remember the big picture. You'll remember it in context. It goes deeper into your heart, deeper into your mind, just deeper into your spirit. And so you can remember those things and understand why, not just like memorizing something, but you'll get it more when you write thoroughly and in context. So let's have a nice, good, solid answer. Now, you shouldn't be filling these out now. Right now, you should be listening to me, right? You know how to do this. And so it says, we have seasons of the year. I'm going to read that again. Because as the Earth revolves around the sun, its axis remains tilted at an angle which does not change. This tilt causes heat and light from the sun to strike the Earth in different ways at different times of the year. Look at the diagram on page 155. So look at 155 while I read. In December, the people in Canada, the United States, and other parts of the northern hemisphere, that's where we live, are having winter because the northern end of the Earth's axis is tilted away from the sun. So it's colder. Remember, you get colder away from the sun. It's colder at night than it is during the day. Okay, because we're away from the sun. And thus the sun rays strike the northern hemisphere at an angle. Therefore, less heat and light reach the northern hemisphere in winter than in summer. Winter days are colder and have fewer hours of daylight than summer days. The people in Australia, South Africa, Chile, and other parts of the southern hemisphere are having summer in December. Think about that. Our winter, our Christmas is their summer. Because they are receiving the full rays of the sun. It's not in an angle. The tilt of the Earth, it's not in an angle. They're getting it like head on, so to speak. And so obviously it's warmer and the daylight lasts longer. They're getting direct sunshine. Summer begins in the northern hemisphere in June. Notice that the northern end of the Earth's axis is tilted toward the sun. Is the northern hemisphere receiving the full rays of the sun? What season are the people in the southern hemisphere having in June? In their Okay, so their summer is our winter. Their summer is December, January, February. Our winter is their summer, okay, like I said, and their winter is our summer. So their winter is June, July, and August, okay? So it's the opposite. So you could see they're here, okay? December, winter. June, summer, winter. Remember, here is, you see the imaginary line? My picture's probably smaller than yours. You see the imaginary line, the equator, the white line, northern hemisphere pointing up. So northern hemisphere gets winter in December and summer in June. Okay? Summer in June. Northern hemisphere, winter December, summer in June. Southern hemisphere, below the equator, summer in December, winter in June. Okay, so you can see that picture. So keep looking at that while I read. In March and September, the Earth is positioned in such a way that neither hemispheres receives direct sunlight. The days are divided quite equally between hours of daylight and hours of darkness. The northern hemisphere has spring in March and autumn in September. Autumn is another word for fall. That's us, the northern hemisphere. Spring right now, March, April, May. Fall, September, October, November. What seasons are people in the southern hemisphere having at these times? Keep in mind that the seasons slowly change. The seasons change slowly as the Earth rotates around the sun. Days gradually get warmer, meaning they do it slowly. It's not like all of a sudden it's really cold and it's really hot. Okay? It's slowly, it moves. God's creation, it's going to work a certain way that's best for us. So days gradually get warmer and longer as summer approaches, and colder and shorter as it gets closer to wintertime. If you live near the equator, you would not notice much of a temperature change throughout the year. The tilt of the Earth at the equator is not great enough to affect the way the sun's rays hit the Earth at this spot. There are seasons near the equator, however, a wet season and a dry season. So if you're living near the equator, your seasons are different. So I want to read that again. If you live near the equator, we don't, we live in the northern hemisphere, you would not notice much of a temperature change throughout the year. Why? You're right in the middle, okay? Not an extreme, just right in the middle. Remember, the equator is the imaginary line that runs through the middle of the Earth. The tilt of the Earth at the equator is not great enough to affect the way the sun's rays hit the Earth at this spot. So it's all pretty much the same. The weather is pretty much the same. There are seasons near the equator. However, it's mostly a wet season and dry season, meaning it's going to rain and rain and rain and rain and rain and rain, and not just like here where it rains for a week and we think that's a big, huge deal. There's a season where it's raining all the time and a seasons where there's no rain, okay? And the temperature stays pretty much the same because it's right there in the middle because of the, it's less of a tilt of the Earth's axis, all right? So in number 7, it says, where on earth would you not notice a seasonal change of temperature? Okay, where is it mostly the same? What did we just talk about? Exactly, near the equator. All right, so you have all of your highlights for today. Do a good job on that comp check. And a lot of interesting things that we don't think about that are Earth. We just, wake up in the morning when it's light, go to bed at night when it's dark. We don't really think about all that's going on during that time. And when we really do, we can see even more the power and the mind-blowing awesomeness of our God and his creation. I'll see you tomorrow.